Good morning. We're at Vessigny Beach here in South Trinidad, and we're looking north towards Merrimack Village, and we are seeing the Brighton Marine platforms in the background there, with a couple of LNG tankers and a few wellheads. To the south of the area, we can see the ALNG plants in Point 14, the Petrotrin jetty there at Point 14. So today we are going to be looking at outcrops of the Upper Morne L'Enfer member of the Morne L'Enfer Formation. So we are starting at the northern end of the beach with porcellanites. Porcellanites are basically clays that have been baked by heat, and the source of this heat tends to be lignites that are embedded between the clays. We can see various colors, mostly red. We can see the remnants of bedding. You can see a variety of colors, which are probably due to a combination of weathering and differential amounts of heat within the rock itself. One thing to note, we do not see lignites within the porcellanites because whatever organic material has been completely consumed by heat. This outcrop extends out into the sea. And let's take a close-up of this. So this is actually lignite, this black material. So we see that there is incomplete combustion, and the material is not pure lignite, it's actually very clay in nature. So we come in the background here and we see the lignite bed. There are no tree trunks and obvious organic material in this outcrop. We see that the lignites grade downwards into a purplish gray clay stone, and actually this apparent contact you're seeing here actually is slumped material. So again, we come up to a lignite bed, and typically these lignites weather to give you a yellow sulfurous type coating. The sharp contact above represents the base of this slip plane where materials come down from the top of the hill. The lignite bed is about 3 feet thick and appears to be thinning laterally towards the south. So here we actually have a fairly substantial tree trunk that is sticking up out of this lignite bed. And we actually start to see things like rooted zones, and if we get a little closer, we see that it is a lot of clay with some organic material, and it grades upwards to a pure clay. So as we walk along, we're seeing bits of plant material, tree trunks and branches sticking up out of the lignites. So occasionally with these lignites, we find these fairly coarse sandy beds within it. Why how that comes about? So here we see another fairly substantial tree trunk sticking up out of this lignite bed. And we see more of this coarse, hard sandstone that covers the lignite in places. So this probably represents some kind of beach rock that may have covered the lignite in the past. Actually, this beach rock is fairly modern because we see a piece of steel incorporated into it. So on the beach itself, we see that there's significant amounts of lignite fragments within the beach, and potentially this is how we get sands with carbon type material incorporated with them in the past. We can also see that there's quite a bit of sparkly material, which are micas, and this is typical of the Pliocene type sands. As we continue further down, we now start to encounter alternating sands and clays, and we notice that these beds are fairly horizontal, which suggests we are either at the base of a syncline or we are walking parallel to the strike of these beds. And as we get closer, we get an idea of some rhythmicity. We see ripples and so on within this section. So we're passing another one of these slumps here. So we appear to have fairly active coastal erosion and consequently retreat of this shoreline. So here we have an outcrop of alternating very thin sands and clay stones, which, as we see once again, are parallel bedded. Let's take a look at a block that has fallen down from higher up in the cliff. We see that in this case it is predominantly clay stone with some thin siltstone beds. These clays are actually fissile and tend to split along sandy plains. We get a little close-up look and we see that we're essentially looking at a fine and upward section. Beds tend to be predominantly parallel laminated, and the bed becomes less sandy towards the top. As we know, there are a number of trees, dead trees on the beach, which confirming that we are looking at fairly significant coastal retreat in places. So as we pass that bit of flatbeds, we come to another outcrop where we start to see some amount of cross bedding. Outcrop is not in very good condition, but we can see within these sandy beds, we see chunks of lignite floating at random within it. So here we can actually see what appears to be the erosional base of some kind of channel, and within this channel we are seeing a lag of lignite fragments which all seem to be oriented parallel to laminations. Here we have a dead bat. Quick look at some of the flora within the area. Pretty interesting, naturally occurring flowers. So we approach another outcrop of fairly, well, it's gently dipping now. Ooh, somebody put up some religious symbols here. So we can look up and see more of these horizontal beds, which are predominantly, in this case, clay stones with thin limonitic layers separating them. Let's take a closer look at what these beds look like from a fallen block. And once again, it's underlain by a sandy clay layer with lignite that are parallel to various laminae. You see another one of these lignite beds that apparently is cut by some kind of fault. So we have gotten to a point now where we see that there is a clear dip towards the northerly direction. In this case now we're looking at beds that are predominantly sand. So we're looking at a bed that is fairly pure sand. There's some faint parallel lamination in it. So we are now approaching the most significant lignite layer within this outcrop. You can see that it forms a groin sticking out into the sea. And we can clearly see now how this lignite grades upwards into pure clay stones. So you can see remnants of tree trunk inside of here, various bits of branches and so on, rooted layers with some fairly abrupt contacts to some of the overlying beds. So this is the groin sticking out into the sea. So we're behind the outcrop now, and we see that this lignite bed is underlain by sand, and it appears to be fairly parallel bedded in the lowermost layer. So here we're actually seeing what appears to be faulting within this section. You're also seeing in some of the undisturbed section cross-bedding, and we see significant amounts of rip-up clasts in areas. So we see here that dips are a lot higher now, again roughly to the north, predominantly sand beds. Within these beds we see clasts of carbonate material along the beds. Some of the beds we clearly see parallel laminated and it's fining upwards and overlain by a zone of breakups. So on the southern side of the salt crop, we see something that appears to be heavily fractured. And there you can actually see some of these fractures that have some kind of fill in them. These fractures are trending roughly northeast and dip towards the southeast. One of the things on the beach, you're seeing lots of green algae on the beach, and that's not a good sign for bathing, because typically these algae are associated with poorly oxygenated waters and pollution. So we're approaching what Kennedy and Saunders in 1965 called beds 1, 2, and 3 of the Upper Morne L'Enfer. So here we see significant fracturing of the rocks, and these fractures are coated with some kind of iron carbonate type material. This here is a clay stone and it doesn't have any obvious sedimentary structures. But what we do see are small burrows, solitary burrows. Actually, we're seeing them in pairs, so they are probably arenocolites, which is a suspension feeder. So here we can actually see two of these burrows. And in bed 2, dips are even steeper. We see a less weathered part of the section. We take a slightly closer look of these sands and their bed boundaries. So those sands form part of bed 2 of Kennedy and Saunders. So we're now approaching bed 1, and most of this bed has been almost completely removed. But what we see, it is really a class supported conglomerate of sands and, well, elliptical rounded class of sands and claystones which have been coated by iron compounds. And dips at bed 1 are the steepest that we find. Up, stratigraphic up is towards the north. So near the base, we're not actually seeing base of the bed because it's covered in vegetation. But what we see is that most of these clasts have some kind of orientation, or it could also represent a storm deposit at the base of a channel. Just beneath bed 1, we come up to a claystone layer that has fairly steep dips. It's almost vertical. And once we pass bed 2, according to the surface geology map, we should encounter a fault that has cut out the lot 7 silt. And unusually, in most of the coastal outcrops, the lot 7 silt is mapped as being faulted out.